Okay, let's have a look at this question here. The area of a square of side x centimeters is increasing at a rate of 8 centimeters squared per second. So one side of the square is x centimeters, it's getting bigger and bigger, and the rate is this, 8 centimeters squared per second. So we need to translate that first sentence into derivative form. Now, it's going to be dA dt. Why? Because it's basically the area, centimeters squared, changing with respect to time, which in this case is seconds. Okay? Now, find an expression in terms of x for the rate of the increase of the length of a side. Now, what does that mean in derivative term? Well, it's just the rate that the side of the square is changing with respect to time. That's what we want to find out, dx dt. Now, this is the bit which can be a bit tricky. Okay, I'm just going to do different colors. So, we want to find out that. This is what we want to find out. We can do this in blue. Okay? You'll always be given some bit of information in these questions. So in this question, we'll do it in black here. You're given what dA dt is. This is what you're given. Now you'll be given it in words. You need to translate it into that derivative form. Okay. The last bit, and this is probably the hardest bit, is this is what you need. Okay? You need something, because obviously at the moment the left-hand side is not equal to the right-hand side in that equation. You need something to link these two together. Okay, what is that? Well, if you notice on the left-hand side, we do not have any a, so we need to get rid of that dA. This is the way I do it anyway. Okay? And on the right-hand side, we need a dx, we need this dx, we don't have any dx here. So if we put in dx here, if you notice what will happen is the dA will cancel with this dA, and you'll be left with, well, you'll be left with exactly that, dx dt. Okay, so like the kind of trick is you're basically trying to get, not that I want too many colors here, this is what you want, okay, and the a's are going to cancel out. So let's look at this. What is dx dA? Dx dA. Well, we basically need some kind of equation that has x and a in it. So if we draw a square, remember a stands for area, so if we draw a square, now one side of that square is x. Now I'm sure you agree that the area of that square is equal to x squared. Now it's very easy to work out from there by differentiating what dA dx is. dA dx is just equal to 2x. Okay? So, but there's a slight issue here. If you notice, that is not what we're looking for. We're not looking for dA dx. We are looking for this, dx dA. But easy way to get around that, all we do is we invert the left hand side and invert the right hand side, so to the power of -1 you could think of it. That's going to be, we're going to flip this side, so that becomes dx over dA, which is what we want, and this will be 1 over 2x. You do this, these are just, you know, it's just like two fractions. I'm sure you'd agree that 2 over 7 is equal to, let's say, 20 over 70. If you invert the left-hand side, that would mean 7 over 2 is equal to 70 over 20. That's just what we've done there. Okay. Now I'll rub that out because that's not relevant for this question. So we now actually have everything we need to solve this, to set up the first part at least. So let's go back here. We know this is what we want to find, dx dt. We've been given what dA dt is. Okay, so we'll just fill in 8. We don't need to put in the units. And what we need, well, we actually have it now. We know what dx dA is. It's going to be 1 over 2x. Now, we multiply across, we do it in blue. We multiply across, we'll get 8 over 2x. Simplify, 2 goes into 8 4 times, we just get 4 over x. Now, it's good to think about what units would be here. Well, x is centimeters, isn't it? So that's just the side of the square. Okay, so this is centimeters, this is time. So it's going to be centimeters. This is how the per second. This is how the length of the side of the square is changing with respect to time. So 4 over x centimeters per second. That's the first bit answered. Now, the second bit is just asking us for a specific time, when the length of one side of the square is 16 centimeters. So the square has got to be 16 centimeters, so x in this case is 16 centimeters. And the question is, find this rate of increase when x is 16. Well, we know what dx dt is for any value of x. So all we have to do, now the way we write it here is we say when x is equal to 16, we do a little kind of line, we do when x is 16, well, we just fill in 16. 4 divided by 16, which is equal to, well, it's just a quarter. Now what units would it be here? Well, the same as before, a quarter centimeters per second. Okay, so when x is 16 centimeters, the square is increasing in size at a rate, the length of a side is increasing in size at a rate of a quarter centimeter per second. Okay, that's it. Tell me if you don't get it.